Okay, so this is going to be a very quick review for the academic chemistry EM spectrum and electron configuration test. As far as these first questions go, I'm just going to kind of fill in the answers and give you a little insight to some of them. First one, light travels as discrete bundles of energy. Each one is called a photon. So the answer to the first one is photon. They have no mass, but they carry little bits of energy. Um, so there we are for that one. The second one, the blank of a wave is the number of cycles per unit of time, or how often a wave passes a point, and that happens to be frequency. How often it happens, how often a wave passes a point, the number of cycles. A cycle is also called a wavelength. Frequency itself is measured in hertz. That's the unit that we use. Okay, so the distance between two peaks or valleys, when you're looking at a wave and you have this kind of thing going on, you see this wave here. The distance between like this point and that point, that's called the wavelength. Okay, so wavelength for this one. The region in an atom where there's a high probability of finding electrons, those are called orbitals. And electromagnetic radiation like radio waves, gamma rays, light, AM and FM waves, they travel, all of them travel at the speed of light, which happens to be 3.00 times 10 to the 8th meters per second. Okay, so you're going to see this stuff on your test. Now, true or false, and that's also on your test. So let's talk about this one. The relationship between wavelength and frequency is direct. That happens to be a false statement, because when you look at waves, the longer they are, until they start getting shorter, like this right here, the longer they are, the less frequent they travel a certain point. So that answer is false. It happens to be indirect. And then the next one, according to the electromagnetic spectrum of visible light, the color blue has more energy than the color yellow. So the color blue does. That is a true statement. And how that works is you've got the Roy G. Biv thing, and over on this side there is more energy, E, and on this side there is less energy. So if you think of it that way, less energy on the left side, more energy on the right side. Red has less energy than violet, orange has less energy than indigo. So if it's more on the right side, there is more energy, less energy on the left side. Okay, according to the electromagnetic spectrum of visible light, the color violet has a longer wavelength than the color orange. That is also false. When you look at Roy G. Biv, let me make this a little bigger. Roy G. Biv, the longer wavelengths are on this side, and the shorter ones are on this side. So the bluer colors have shorter wavelengths than the red, orange, and yellow colors. Okay. When color is seen in the visible spectrum, it is the result of an electron absorbing energy. That is also false. The correct statement would be when it emits or gives off energy, and the capital E for energy. When it does that, then you see light. Okay. 1s2, 2s2, 2p3 represents which element? And all you really got to do is look at this part right here. And if you go to the periodic table, Here's the second period. This is the P block here. This is the S block. This is the D block down over in here. So 2P3 would be in this period here, and 1, 2, 3, and that happens to be nitrogen. Okay, that's all you have to do for that. How many valence electrons in the element above? There's two ways you can do this. One is you can look at the energy levels, and if I get rid of that right there, I can look and see the highest energy levels here are these 2s. What I would do is add that 2 and add that 3, and I'd give a total of 5 valence electrons for that. But the other thing you can do is you can go to where nitrogen is and just look at the number above the group, and that'll tell you the same thing, the number of valence electrons. So let's go back to the review. How many electrons are in the d orbital? Well, if you look at it, I'm going to go back to the periodic table. Here's a d orbital. Every little block like this one here represents an electron. So all you have to do is count up how many blocks are in the d orbital. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons that can be held in the d orbital. In the s, you see they have 1 and 2 for each period. And in the p, we have 1, 2, 3, 4, 5, and 6. So if we go back to our review, the d orbital has, we said, what, 10 electrons? And the s orbital, we said 2 electrons. And the p orbital, we said 6 electrons. All you gotta do is count up how many blocks in a period for each one. All right, so let's go. Let me get out of this. Let me go to the second part of this. This is noble gas notation for the electron configuration for each element or each atom. Noble gas notation. So we have AR 4s2 3d10. Don't let any of this confuse you. All you got to really do is look at this part right here, 3d10. So we know that we have to start at 4s2 right there. Well, 4s2 happens to be, here's a fourth period. This is the s2 part of that right here. But when you get down to the d block, it drops down one number. So 4 becomes 3. In the fifth period, 5 becomes 4 when you get to the d block. So 3d10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that happens to be zinc for that one. So zinc, Zn, or zinc, like that. How many valence electrons? Look at the highest energy level. This one happens to be 4, right here. But you look at that number right there, and that tells you everything. 2 valence electrons for that one. Which color is the most energy? Well, let's look at Roy G. Biv. Roy G. Biv. And that would be violet on that one. And then the lowest frequency, that would be at the other end, and that would be red. So most energy would be violet. Lowest frequency would be red. Okay, so getting down to the very end here, consider the following electron configuration for the following questions. How many total electrons are present in the above atom? The way you do that is by looking at the superscripts for each one. That, and that. And you add them together. So we have 2, 4, 10, 12, 18, 20. There are 20 electrons in that atom. The identity of that element, all you have to do is look at that last little bit, which is right here, 4s2. And I can tell you, by looking at the periodic table, 4s2 is right here. That's the S block. Happens to be calcium. And so, let me write that in there. Calcium. How many valence electrons? Well, calcium is in group 2, plus this one has the highest energy level, so we have 2 valence electrons, 2 VEs, 2 V E's. And the noble gas electron configuration for scandium, which happens to be SC. All right, so when we go and we look at it, we look at the noble gas right before that next period. So we're looking at scandium. Let me erase some of this stuff so we can see a little better. Scandium happens to be right here. So we look at the noble gas that's right before it. It happens to be AR, which is argon right here. And then all you have to do is write whatever comes after it. And so we have to write what these are. That happens to be 4s2. And we drop down to the third. We drop down to a 3 when we hit the D block. And that happens to be 3D1. And so your answer happens to be, let me go back to what I was talking about. Write down AR, 4s2, it has to go in brackets. Remember, it's the noble gas right before it. AR, 4s2, 3D1. And the very last thing is labeling the crest, the trough, the wavelength, and the amplitude for transverse wave. And so let's draw a transverse wave real quickly. And go like this. And I'll draw the wave as best I can. Okay, something like that. The crest is always the top part of the wave, which is right there. Highest point of the wave, and it's also right there. The trough, I'll put it in green, happens to be here. And it also happens to be over here. And then the wavelength happens to be the distance between the crest and the crest, which is right there. That's wavelength. I guess I can put that in red. Wavelength here. And there's also wavelength here. Okay? And then the amplitude is the height of the wave or the depth of the wave. I'm going to put that in orange, I think. So this is amplitude here. And this is also amplitude from this spot called the origin. Okay, that's what most of your test is about anyway. I hope this has helped you. Good luck.